Avançamos? Okay. Very good. Good afternoon to you all, and welcome to this session. Here we have a plenary session about math education, and we have the pleasure to have with us Marie Bocquillon, the University of Mons in Belgium, and she is going to present this work about explicit instruction in math. And so it's our great pleasure to be here with her and to listen to her talk. She will talk for about 40-45 minutes. We have time, and then we'll have about 10-15 minutes to raise questions. So very welcome, and thank you very much, Marie, for being here with us. Please, the floor is yours.
Thank you. Bon dia. Hello, everyone. I'm Marie Bocquillon from the University of Mons in Belgium. First of all, I would like to thank the organizers for inviting me to give a lecture during this very interesting conference. It will be my pleasure to tell you more about explicit instruction, an example of an effective pedagogical approach to promote the success of the greatest number of students. To introduce the subject, I would like to start with a question that all teachers ask themselves. How do I choose the teaching strategies to implement in my classroom? Every teacher is confronted with a multitude of sources of varying quality from which he or she draws inspiration. Thus, his or her practices may be influenced by the practices of his or her former teachers, by the practices of his or her colleagues, by the advice he or she has received in pre-service or in-service training, by the opinions of parents, and the teacher and all these people are also influenced by what they have experienced as students, by the image of the teacher conveyed in movies or in novels, by pedagogical books, by professional journals, by textbooks, by the internet, by websites where teachers share resources with other teachers, by social networks, and so on. This situation could be comfortable if, according to a widespread idea, all pedagogical approaches were equally effective. However, this is not the case. On the one hand, we find practices validated by scientific evidence. This is called evidence-based education. And on the other hand, we find practices based on traditions, beliefs, or fads. For example, explicit instruction is a pedagogical approach that has been shown to be effective for student learning in a large body of empirical research, while the learning pyramid, a popular idea in education, is not supported by any evidence. In short, some practices are more effective than others. So here is the plan of this talk. First, we will agree on the definition of effectiveness that will be used during this talk. Second, we will discuss how the research to demonstrate the effectiveness of some practices is conducted. We will then focus on a pedagogical approach that has been shown to be effective for student learning, namely explicit instruction. Finally, we will briefly present another study conducted in the field of mathematics and showing the effectiveness of explicit instruction, namely the study by Guilmois. So, what effectiveness are we talking about? According to Bloom, effective teaching corresponds to three inseparable effects: an increase in the mean of all students' outcomes, a reduction in the variance of all students' results, and a decrease in the correlation between the social origin of each student and more generally his or her characteristic and his or her results. So according to Bloom, effective teaching is therefore equitable teaching because we care about the success of of all students and not only the good ones. So we agreed on a definition of explicit teaching, but how do we know what is effective? To answer questions about the effectiveness of teaching, it is important to use evidence from rigorous classroom research. There are different levels of evidence in education, from the weakest to the strongest. I therefore present here a taxonomy of levels of evidence adapted from, for instance, from the work of Ellis and Fox. So in education, we too often rely on testimonials, personal anecdotes, or expert opinions. These are interesting elements, but they are not scientific evidence. And in order to start talking about scientific evidence, we need to refer to descriptive studies, experimental studies, and meta and mega analysis conducted in a rigorous manner. The higher up the pyramid you go, the higher the level of evidence is. To make this taxonomy more concrete, let's apply it to the example of explicit instruction to show you where this model comes from. The first thing you need to know about explicit instruction is that it's not a pedagogical approach invented in a theoretical way by researchers. It is a pedagogical approach that emerged from descriptive research. This type of research works as follows. Researchers took the time to sit in classrooms, to observe teachers' practices, and study the correlations between those practices and student outcomes. In this way, they realized that some practices, such as reviewing, demonstrating, or giving feedbacks, were associated with greater student success. However, at the time, they were not sure that the observed practices were the cause of higher student achievement, as a correlation does not determine a cause and effect relationship. So these researchers then conducted experimental research, such as the one by Good and Gross, conducted in the field of mathematics, which is one of the first studies of this type, or the more recent research by Guilmois, which I will talk about at the end of this talk. This type of research works as follows. The researchers work with two groups of teachers. The first group is a group of teachers trained to use interesting practices identified in previous descriptive studies. Remember, we talked, for example, about reviewing, demonstrating, or giving feedbacks. And the second group is a group of teachers who continue to teach as usual. This is the control group. Ideally, researchers should randomly assign participants to different groups to control for factors that may bias the results. This was done, for example, in the study by Good and Gross. The researchers then compare student outcomes before the experiment and after the experiment. This is called a pre-test and a post-test. The results of these studies show that the students of teachers trained to use the interesting practices identified in the descriptive research did indeed perform better than the students in the control group. This type of research allowed the researchers to show that it was indeed the teachers' practices that caused the students better results. And that's from this kind of research that comes explicit instruction. Since a lot of experimental research has been conducted since the 1970s, it is now possible to synthesize it into large research summaries called meta and mega-analysis. A meta-analysis is a synthesis of experimental studies, and a mega-analysis is a synthesis of meta-analysis. However, one must be careful with this type of research because a meta-analysis or mega-analysis is only as good as the underlying studies that it aggregates. I will now briefly present the results of a rigorously conducted mega-analysis. It is the one conducted by Steve Bissonnette, Mario Richard, Clermont Gauthier, and Karl Bouchard. Its purpose was to answer the question, what are effective instructional strategies fostering basic learning among struggling primary students? During this conference, I will focus on the results of this mega-analysis that concerns mathematics. As far as methodology is concerned, the authors selected meta-analysis that answered their research question based on rigorous selection criteria. For example, each selected meta-analysis had to analyze a majority of studies that used an experimental or quasi-experimental research design with a control group. 3 meta-analyses in mathematics were just returned, representing 90 studies involving 5,230 students between 1971 and 2006. The meta-analysis of Baker and his colleagues, the one by Roosbergen and Van Luit, and the one by Kunsch and his colleagues. The results indicate that explicit instruction and reciprocal teaching, which we will discuss in the next part of this talk, are more effective in teaching mathematics to struggling and at-risk students than constructivist pedagogy. We will now focus on an example of an effective teaching approach, explicit instruction. So the term explicit refers to visible teacher and student behaviors. ATI uses the terms visible teaching and visible learning to emphasize that instruction must be visible and explicit to students, and that student learning must also be made visible to the teacher through the checking of understanding and the use of feedback. By using explicit instruction, the teacher tries to make explicit what happens in class, for example, the procedures, the objectives, considering that the implicit can be harmful to learning, especially for the weakest student. So explicit instruction is a very rich pedagogical approach with many steps and professional gestures to implement during 3 main phases: preparation, interaction with students, and consolidation of learning. When we train teachers in this pedagogical approach, we spend several days with them to train them in all these steps and gestures. In this conference, I will focus on three key steps of this approach, which distinguish it from socioconstructivist pedagogy on the one hand, and from lecture-based teaching on the other. These 3 key steps are modeling, guided practice, and independent practice. During the modeling, the teacher demonstrates the task at hand by thinking aloud and using many examples and counter examples. This is a short step lasting a few minutes. 2 components characterize the modeling of a skill: the demonstration of the sequence of actions to be performed, and the description aloud of the decisions that are made during the action. So there is just a link between this verbalization aloud and the concept of metacognition. During guided practice, students complete tasks similar to those shown during modeling with other students and the teacher's help. Several modalities are possible. The teacher may ask students to resolve a problem under close supervision and then send a few randomly selected students to the board to complete the exercise and verbalize it to the others. Another modality is to use reciprocal teaching at this stage. Concretely, students must work in pairs. For example, if the lesson is about written multiplication, student A must carry out a written multiplication in front of student B and explain the process he or she puts in place. There is also a link with the concept of metacognition. Then the roles are reversed. Student B must perform another written multiplication in front of student A and explain the process. These 2 modalities can be combined during the same lesson. Whatever the guided practice method, the teacher constantly checks the students' understanding and provides them with feedback and appropriate scaffolding. Each student must obtain a minimum of 80% correct answers before moving on to the next stage, the independent practice. During independent practice, students reinvest what they have learned in modeling and guided practice independently. The teacher's scaffolding is reduced because the student is more independent. The goal of independent practice is to provide students with enough practice to allow them to integrate the new knowledge or skill with their prior knowledge or skill, as well as to implement the skill automatically. In order to do this, it is important that students complete enough independent practice in length and in number of drills to reach automation. It is also necessary for students to practice in different contexts to ensure the transfer of acquired skills. And the target success threshold here is 95% correct responses per student. Explicit instruction is therefore a pedagogical approach that allows true differentiated instruction. Indeed, the 3 steps I just presented should not be seen as stages following each other in a linear way, but rather as an iterative process. If one or more students are in difficulty, it is always possible to go back to the previous stage with them. For example, if we realize that a student is not ready for independent practice, we can propose a new guided practice or even a new modeling. After this brief introduction, you may have realized that explicit instruction is quite different from other teaching approaches. For example, in a lesson following the principles of socioconstructivist approaches, students are usually asked to complete tasks alone or in groups. The teacher then demonstrates the procedures only when necessary. Whereas in an explicit instruction lesson, the teacher first demonstrates and verbalizes the procedures. This does not make explicit instruction a lecture. In a lecture, the teacher gives a presentation, which is not necessarily a modeling, and then provides students with exercises that are similar to independent practice. Guided practice is not organized in a lecture, although it is a key step in explicit instruction. Now that we have seen what explicit instruction is and that we have distinguished it from other teaching approaches, it's interesting to understand why is explicit instruction effective. And this question can be answered by research in cognitive psychology. Firstly, Gary's research has shown that we do not learn academic skills such as mathematics in the same way as we learn natural skills such as walking. While walking is learned through discovery, academic learning is developed through explicit instruction that respects the cognitive load of learners. This has also been empirically demonstrated through Sweller's research that proceeded as follows. A group of students were asked to solve algebra problems independently through discovery. And another group of students was also asked to solve algebra problems, but after studying examples of problems already solved. This is called worked examples. The results indicate that the group of students who studied the procedure before solving problems were more successful on subsequent problems as well as on transfer problems. It was also this type of research that showed that some learners in the first group faced with solving problems without models were able to find the solution without being able to remember the procedure used to find the solution. Nevertheless, my presentation should not give you the impression that explicit instruction must be used in every lesson and that socioconstructivist approaches, such as the discovery learning approach, should not be used at all. However, it is important to use specific criteria, not preference, when choosing which teaching approach to use in a situation. When the teacher is addressing students with a low level of competence, when many of whom are experiencing difficulties, when the task given is new or complex, and when the time available is limited, it's appropriate to use explicit instruction. Conversely, when the teacher is dealing with students who have a high level of competence, when the task given is known or simple, and when there is sufficient time available, it is possible to use discovery approaches where the level of scaffolding required is minimal. Furthermore, the teaching of the main ideas of a curriculum should ideally be explicit because these contents require a high level of scaffolding for students. And again, research in cognitive psychology has come to the same conclusions. Cognitive load theorists do not advocate using all aspects of explicit instruction all the time. Indeed, they recognize the need for learners to be given the opportunity to work in groups and solve problems independently. But they assert this should be used as a means for practicing newly learned content and skills, not to discover information themselves. Andrew Martin, for example, advocates a teaching model that is explicitly designed around cognitive load theory and the constraints of working memory. He suggests, however, that less structured approaches can also be an effective instructional method for students who are further along the novice expert continuum, if such instruction is designed with the constraints of working memory in mind. I will now briefly present the results of another experimental study conducted in the field of mathematics and showing the effectiveness of explicit instruction. This is the thesis defended by Céline Guilmois under the supervision of Bertrand Troadec, Steve Bissonnette, and Maria Poparoc. I thank Professor Bissonnette, with whom I prepared this part of the talk. This thesis focuses on numeracy education and compares the results of students divided into 3 groups based on the pedagogical approach used by the teachers. One group that mobilized explicit instruction, one group that mobilized socioconstructivist pedagogy, and one group of teachers who continued to teach as they usually do. The participants were students coming from priority education zones, which are called REP and REP plus in France, which are also priority education zones, but where the level of disadvantage is even higher. 3 studies have been conducted by Céline Guilmois. The first study focused on the teaching of subtractions and involved 454 second grade students divided into the 3 teacher groups already mentioned. A second study focused on division and was conducted with 267 fourth grade students divided into the 3 teacher groups. And the first study focused on the study of area and was conducted with 301 fifth grade students divided into the 3 teacher groups. This is one of the largest experimental studies conducted on the subject. In all 3 studies, the same procedure were used. Students completed a pre-test before the experiment, and the same test was used at the end of the experiment. This is called the post-test. Teachers in the explicit instruction group were given scripted lessons to implement in their classrooms. These were lessons that gave them a lot of details about what to do and what to say in class. Teachers in the socioconstructivist pedagogy group also received scripted seconds. The usual teaching group did not receive scripted materials. A set of elements were standardized. All groups conducted the same number of sessions. The sessions were of the same length. The manipulation time was identical. And in all cases, a problem-based entry was used. The results of the subtraction study indicate that students in the explicit instruction group, in blue on the graph, perform better on the post-test than those in the socioconstructivist pedagogy group, in green on the graph. The explicit instruction group also performed better than the comparison group, in red on the graph. The students in the socioconstructivist group performed better than those in the comparison group. And it's important to note that during the pretest, all groups were equivalent. The results of the division study indicate that explicit instruction allows students to perform better on the post-test than students in the socioconstructivist group and in the comparison group. This time, students in the comparison group outperformed those in the socioconstructivist group, but the difference was not statistically significant. And again, during the pretest, all groups were equivalent. The result of the third study on calculating areas show exactly the same pattern as the second study. Students in the explicit group perform better than those in the two other groups. Again, the comparison group performs better than the socioconstructivist group, but the difference is not statistically significant. Again, during the pretest, the groups were equivalent. In summary, these three studies again provide very strong evidence for the effectiveness of explicit instruction. For more information about this thesis, you can consult the three following links. So the whole thesis is available in French through the first link. You can also find the publication in English from this thesis through the second link, and a short text in Portuguese was written by Clermont Gauthier and myself from the English article I just quoted, so you can consult it through the third link. Thank you very much for your attention. You can also consult the website on explicit instruction created by my colleagues and myself, or follow it on Facebook or Twitter. It offers resources on explicit instruction in French, English, and Portuguese. Thank you very much.
Thank you, Marie. Thank you very much. Thank you for your presentation, right on time. And I think it was very clear, everything very clear. So we have time now for some questions. I'm waiting on the chat link for people to post their questions. So please do so. And meanwhile, I'll ask you 2 or 3 questions. Is that okay, Marie?
Perfect.
So my first question is regarding the last study you presented from Guilmois. Am I right? Guilmois. And
Yes.
it's a study about the comparison of 3 methods of instruction: the explicit instruction, the control group, and the socioconstructivist approach. For how long did this study last, and when were they measured the initial competence for the students and the final ones?
I should go through in the text, but I'm sure this is a very serious study. So I think the time between the sessions were quite sufficient.
Okay. Okay. Well, that would be nice, but we can't see that on the studies, correct?
Yes.
Could you help us describe a little bit better what's a typical control group classroom, what's a typical explicit instruction classroom, and what's the control group? Because what I'm seeing, and correct me if I'm wrong, from this is that the control group and the social constructivist got more or less the same results at the beginning and at the end, more or less the same results. So it seems maybe that the control group is following some constructivist approaches or not. And
Okay.
that's my question. If you can answer that, because you didn't do the study, you just are reproducing it. Yeah.
Yes, that's my position. I agree to talk a little about this study, but it's not mine. So I refer you to the texts that are very interesting. But I can answer that question because what's great in Guilmois' study is that the true experimental groups have scripted lessons. So the explicit lessons was conceived by Céline Guilmois with Steve Bissonnette. So it respects the different stages of explicit instruction I just described before during my talk. And the socioconstructivist lessons were also scripted by Céline Guilmois and specialists of that teaching approaches. So they all agree that the explicit instruction lessons were explicit and socioconstructivist lessons were socioconstructivist. And the control group did not receive any material. So that's a very strong result, is that the scripted lessons, the socioconstructivist scripted lessons did not perform better than any practice from the control group. So an hypothesis is that yes, the control group maybe use also some kind of socioconstructivist approach, but without material, maybe because in France it is a widespread teaching approach. Is that, do I answer your question?
Yeah, I think so. I think you answered my question. Although it's not very, what I'm still not clear about is what would be the social constructivist approach? Would it be just to raise questions and help and hope that students answer the questions? Because, and is this for elementary teaching, or is this for a more advanced teaching only? Because you made this distinction, and that's the part that I'd like to understand better, is that you made this distinction between the novices and the experts. Let's say people that are at the beginning stage, they need a more direct instruction. They need like instructions. Do this way. See how I did, you do now. And people who are not like that, they would like to do by themselves. They can benefit from, benefit from other more free approaches.
Yes.
Is that what you said?
So the main difference I tried to explain is that in explicit instruction, the teacher first demonstrates how to do the skill and verbalize the steps, the actions to be made to the students. And in socioconstructivist approach, the student first need to look by himself and to search the solution himself before the teacher helps him. And what research tell us since 50 years now is that this configuration, the student looking himself without the teacher's help, is harmful for the weakest students, the novice, or the students having difficulties. But for more advanced students who have always a base or certain knowledge and skill, that configuration could be okay for them, but only if they have the prerequisite skills for that.
Very good. I have now two questions that I'm going to read. I'm going to translate them into English. Let me see if I'm translating this well. Guilmois' study was done only in Guadeloupe, or was it done in other academies, so in other schools? That's the first question. Maybe you want to ask that, and I'll raise the second question next.
Yes, so it was indeed in Martinique. Oh. It's one of the first. In reality, it's one of the only experimental studies done in French-speaking countries, because we have a long tradition of that kind of research in United States or in England, so in English-speaking countries. In Europe and in French-speaking countries, there are unfortunately not much studies of this type that are conceived. So it was only in Martinique, but in a long, on a big number of students, and the results are confirming a long tradition of English research since the very first one I just quoted from Good and Gross, that was in the 80s, I think, about the teaching of mathematics.
Okay, just to confirm for this question, people might be interested in knowing where to find these English references. So this Guilmois' dissertation has these English references of previous studies, does it?
You can also find in my own thesis on that website, because I do a research a little historic from the beginning, and so you can see, but I'm not a mathematician, so you will find things that are more general and sometimes about math, but you can find this reference in English in my own thesis that is available on this website.
Okay, very good. I have a second question here, which is the following. How can you be sure that students learn the subject and that they didn't just do a good preparation for a certain test? This is a very important question. I don't know if you know about this study, but this is a more generic question. Maybe you can help us in this regard.
Okay, so it's a very interesting question. It's a question that can be asked for all experimental studies. That's what are we measuring? But it's a really tough question, because, and that's why in French-speaking countries, that is one of the main critiques of the research I just presented. It's what do you measure? Are you sure you measure learning? I understand the question, but in order to do that kind of research and to be able to distinguish what works in education, we have to find a solution. It's maybe not perfect, but it has to be measurable. And thus, in that kind of research, we measure learning with a test that is usually standardized before, and then we have weeks or months, and we do the same test, and we can compare the different groups. What I could answer also, but I'm not sure to translate very well, is that if the student just study for the test, how can we explain that the groups are so different at the end? I think so all the students are smart and can study for a test, so we shouldn't see a very strong difference like the one I just show you. But I agree it is a very tough question, but we need to find things that are measurable in order to compare different pedagogical approach. If we don't do that, we will always be talking about education with our preference, and my opinion is not what I want to show you. I want to show you evidence. So yes, there are limits, but it's better than just me telling you what the best pedagogical approach is.
Very good. I have a final question here.
Okay.
We still have, I ask you to be brief, and that question complements this previous question, actually. It's the following: the tests, pre and post, that determine the results, are they based on the explicit approach or on the socioconstructivist approach?
They are based on the final objective that is in the subtraction study, to be able to do different kind of calculations. So it's the same process for all the groups, and they are not, to my knowledge, they are not based on a pedagogical approach. It's the final objective. It's not, the pedagogical approach is the way you use to get the student to the objective, but the test is neutral, if I can say. It is based on the curriculum, what a student of that grade should be able to do at the end of a sequence about subtraction, for example.
Okay, very good. Well, thank you very much, Marie. Unfortunately, we are not in a real room. We are in a virtual room, so we can't thank you properly, but I'm sure that everybody enjoyed this session. And I'm going to just tell people that this discussion about math teaching is going to continue on a parallel session that will take place right now, right at the hour, at the Pedro José da Cunha room. And by the way, Pedro José da Cunha was the first president of the Portuguese Mathematical Society in 1940, if my memory serves me well. And so this is a kind of small homage to him. So thank you very much again, and see you in the next room.
Thank you.
Bye-bye. Thanks, Marie.
Bye-bye.